Alright, algebra kiddos, this is skill 2.8, multiplying and dividing radicals. So you had just finished simplifying radicals using the perfect squares method. Okay, so we're going to revisit that right here. So the example is to simplify the square root of 56. Well, our first thought that comes to mind is 56 a perfect square? Well, if you go back to your table that we filled out, 56 is not a perfect square. Okay, so from that point, we want to know, is there a number that goes into 56 that is a perfect square? So the way you go about that is you start with the largest one. The closest one to 56 would be 49. That doesn't go in. 36, no. 25, no. 16, no. 9, nope. 4, yes. We know the square root of 56 is equal to the square root of 4 times 14. Okay? Well, thanks to the product property of radicals, we can take this one radical and break it into 2. So that's the square root of 4 times the square root of 14. This guy right here is huge. Okay? Now we'll be talking about that in a little bit. Okay? So to finish this problem, we have square root of 4 times square root of 14. Well, is 4 a perfect square? You bet. So the square root of 4 is 2. Is 14 a perfect square? No, it is not. But does it have any perfect squares that go in it? No. Okay? So our final answer is 2 times the square root of 14. Okay? That's our final answer. So what we're going to dig into deeper is this product property of radicals. Okay? Because we're going to be multiplying radicals. All right? So if we move on to the next slide, it says to evaluate the square root of 2 times the square root of 6. Okay, so the way we would begin is, can I simplify either one of these radicals? Well, you take a look at it. 2 is not a perfect square. Can't do it. 6 isn't a perfect square, and nothing goes into 6 that would be a perfect square. So we're left with this part right here. 2 times the square root of 2 times the square root of 6. Well, again, with the product property of radicals, we can take a multiplication problem of 2 radicals, combine it into 1. Okay? Now the reason why we can do this is because it's multiplication. Alright? So we can combine when we have like radicals. So we know 2 times 6 is equal to 12. Okay? This is a great point to be at. Now we go back to our 2.7 skill and we simplify. Is 12 a perfect square? No, it's not. But is there a perfect square hiding in 12? You bet. 4 times 3 is 12. So we have the square root of 4 times 3. Okay, again, we can break this down into 2 radicals. So that is square root of 4 times the square root of 3. Okay? Well, can we take the square root of 4? You bet. That's 2. Notice that I'm not writing square root of 2. We've used the square root on the 4 to get 2. That's why there's no more square root. Can we take the square root of 3? No, it's not a perfect square, and no perfect squares are factors of that 3. So this is times the square root of 3. Okay? So I want you to notice, we started with 2 radicals to get to 1. Then we went to 1 radical to break it down to 2. Okay? So if we were to look at the general property itself, we have the product of A times B, which is equal to the product of A, or the radical of A times the radical of B, which then can go back into what we just had, A times B. Okay? That's kind of what we're doing. That's the process that we're handling when we're multiplying radicals like this. All right? So I'll just give that a little more. Again, this is the product property of radicals, PPR, product properties of radicals. Okay? Good. So let's try another example. All right, we're going to evaluate we're going to evaluate 3 square root of 2 times 4 square root of 6. Okay? Well, what do we really have right here? I have 3 square root of 2. The question we want to ask ourselves is, how is this 3 connected to that square root of 2? What operation do we use when a number is next to a grouping symbol? Okay? Because the way you look at radicals, it's a grouping symbol. Well, it's multiplication. So we have 3 times the square root of 2. Well, we're multiplying that by 4 times the square root of 6. Okay? So I know there's a lot going on right now. But is there a way that we can change the order of this problem to make life easier on us? You bet. The commutative property says that order does not matter when you're working with multiplication. And the way these items are all connected is by multiplication. So I'm going to put like values by other like values. So I'm going to put the numbers outside the radicals. I'm going to put those together. Okay? So I'm going to do 3 times 4. And then I'm going to put the radicals together. Times the square root of 2 times the square root of 6. Okay? So now I can multiply it. The thing about this is you can only multiply numbers outside the radicals with each other, and you can only multiply radicals by each other. You can't multiply those two together and expect to get the square root of 8. That is incorrect. Okay? So don't do that. If it's on the outside, it stays with the outside. If it's with the radical, it stays with other radicals. Okay? So, if we go ahead and solve this problem. Okay? Well, 3 times 4, we know that to be 12. Okay? Well, the square root of 2 times the square root of 6 is equal to the square root of 2 times 6, which then results into to be square root of 12. Okay? So right now we have 12 times square root of 12. Okay, again, we cannot combine these two because this one doesn't have a radical and this does. So, that further but we can still simplify that square root. Well, we know that it can break down into the square root of 4 times the square root of 3. And that ultimately gets us a 2 on the outside, because we can take the square root of 4 times the square root of 3. So we can continue to bring down this 12. Just like we did here, we were able to multiply the things on the outside of the radical. Likewise, we can do the same here. So this becomes 24 times the square root 3. That's our final answer. So again, to go over the process, we couldn't simplify the radicals, but we could change the order thanks to the commutative property. We combine what we call like terms, 3 and the 4 on the outside, so therefore we can multiply those. The 2 and the 6 both have the same radical, square root. Combine those, simplify that radical. We get that. Once we've simplified, we've got a number on the outside, so we can combine it again with the other number on the outside. Okay? So, it's your turn. Go ahead and try these two problems. Square root of 8 times square root of 14. 5 times square root of 24 times negative 3 times square root of 6. So go ahead and pause now and simplify. Alright, so you've just got done pausing. You're working with this now. Let's go through the steps. The first thing we want to try to do, and this problem to the left, is we want to see if we can simplify before we multiply. Now take a look at the square root of 8. Is that a perfect square? No, it is not. But is there a perfect square hiding in 8? Well, we start with the largest one that's below 8. Well, the largest one below 8 is 4. Well, we know 4 times 2 makes 8. So I have the square root of 4 times the square root of 2. And I still have this square root of 14. So let's see if we can break this down. Well, 14 isn't a perfect square. 9 doesn't go into it. 4 doesn't go into it. 1 does go into it, but that still doesn't help our situation. Okay? So it stays the square root of 14. Okay? Well, I take the square root of 4. You bet, it's 2. And I have 2 times the square root of 2 times the square root of 14. Now again, I can only combine things that are on the outside of the radical together, and I can only combine things that are inside the radical together. Okay? Well, this has nobody to combine with right now. This guy does. Square root of 2, square root of 14, they're both inside the radicals. I multiply those together. I get the square root of 28. Okay? So we can take two radicals, combine it into one. Well, now I gotta see if I can simplify. Is 28 a perfect square? No. Is there a perfect square hiding in 28? Well, I start with the closest one. 25 can't go into 28. 16 can't go into 28. 9 can't go into 28, but 4 can. Right? So now I have 2 times the square root of 4. 4 times 7 is 28. Can we take the square root of 4? You bet. We are amazing 2 times the square root of 7. And again, you can combine things on the outside of the radical when it's multiplication. That's key. When it's multiplication, we can do that. So 2 times 2 is 4. So we have 4 times the square root of 7. Okay? Good. Moving on. Let's try this guy. Well, so I apologize. I had to skip ahead because of some technical issues. So what happened here was we were able to break down the square root of 24. Okay? You can break that down into the square root of 4 times the square root of 6. Again, can we take the square root of 4? You bet. So now we have 5 times 2. That's what we get with the square root of 4. I'm going to go ahead and move this negative 3 over because, again, I'm going to put my like terms with my like terms. The outside with the inside. So this is times negative 3. Then I'm going to move the square root of 6 over. Square root of 6 times square root of 6. Out. So I can multiply what's on the outside, and I can multiply what's on the inside. Well, 5 times 2 is 10, times a negative 3 is a negative 30. And when I multiply two square roots, I can get one square root, and that's the square root of 36. Okay, well, Now we're going to see if we can simplify this radical. Well, guess what? You can. Take a look at this. Square root of 6 times the square root of 6 is the square root of 36. 36 is a perfect square. Well, take the square root of 36, what do we get? 6. Radical's gone. So I want you to notice, when you take a radical with the same number inside and you multiply it by the radical of the same number inside, it just cancels the radical and you get 6. Okay? So we take the radical of the same number inside times the radical of the same number inside, you get that same number. And when you take negative 30 and you multiply it by 6, you get negative 180.